Hey, today I'm going to be showing off my Bezier curve project. The meat and potatoes of the project are these two functions. Um, this takes in a list of control points and the Bezier curve degree and a resolution. So the control points are all the different points that affect the Bezier curve. The Bezier curve degree is how many segments each curve is going to be. So if there's 5 points, you can have a 4-degree Bezier, or you could have two-degree Beziers. So um, this just takes each segment and turns each segment into a Bezier curve, and down here that actually gets, this is what generates the points. So we get the closest whole number to the resolution. So sometimes we want to have a Bezier curve with a higher resolution, maybe if it's closer up. So that could be used to do that. But then, of course, we need to have a integer number of steps to go. So we need to just get as close as possible to that integer. So we get a Bezier point for each step along the curve, and then here is the recursive call. So if there's 2 control points, that means we're done, and we just do the linear interpolation between the 2 points. And if we have more than 2, we go through each pair and linear interpolate, and then for each of the new points halfway between each pair, so n minus 1 new control points, we use that as the new control points and pass that into the same function, just do a recursive call. So, show that in action. What I have here is a square wave with 25 points, so 24 segments. And then I have done each one of these Bezier curves is 1 degree higher. So this square wave is a 1-degree Bezier curve, which is just the curve. It's just straight lines between all the control points. And then this one is each segment is a degree 2 Bezier curve. So it's got 3 points. So the point here, the point here, the point here. And then so on. So you get some really interesting things here from them. And it goes all the way up to 24 degree. So it works at arbitrary levels. And these are statically generated, so they don't take up any extra processing power in like at the time that it's running. It just on startup takes a little bit longer, and it's really not that much, because even a 24 degree curve, it's doing a lot of recursive calls, but you only have to pay that price once. So let's go back up here. Notice that the curves are not they're not smooth, but that's a feature. That's a problem with Bezier curves, anyways. So we would have to do like B splines or some other sort of spline to get it to be smooth across. Also, I'm not doing any sort of, like, this curve here is completely separate from this curve here. I would have to take into account the control points over here to make this little cusp become continuous. So there's a really good video by Freya Holmer about Bezier curves and splines. She was doing something pretty different from what I'm doing, but the other thing is that these are capable of being in three-dimensional space. I just didn't make a demo for that, but it just does the same interpolation in 3D space. So let me go ahead and show how we set these up. So for each model, we just create an instance for that model, so that holds the location data and rotation data. And then for the model, we just pass in the control points, the degree we want it to be at, and the resolution. And unfortunately, okay, so this right now is a constant number between each control point. So the end of each segment is gonna always take 100 vertices. So if the vertices are really far apart and it still takes 100, it will be blockier. So I'd like to, this would be great if it was dynamic. That would make the cost at runtime higher because we'd have to adjust them, but there might be a way to do that without incurring a ton of cost. The other problem is if the sections are really, really short, and then we've paid a ton of cost for more vertices in an area that's maybe smaller than a pixel. So it'd be good to do that based on what are the distances between all of the control points. I'm sure there's some sort of heuristic that we can do. Also, I'm just gonna quickly go ahead and maybe make some of these control points a little bit higher. That way we can see it in 3D. I have no idea what this is gonna do, so just trying it out. I assume that it won't look super great. And then we'll just see how it goes for all of them, because they're all using the same control points. Yeah, so the square wave obviously looks bad because it's very steep, but then the other ones have a lot less problems. It's pretty interesting. Yeah. So you can see the variation in the degree a little bit better with this. So pretty cool. Yeah, and there's really no limit to how this could be used. It would be interesting to see this as like a sort of a line graph, a three-dimensional line graph. That might be interesting. Anyways, that's all I have to show.